In our previous segment, we learned how Newton's second law of motion is related to the momentum of a system and is given by this. And then we also found out that if there was no external force acting on the system, so if F was equal to 0, then momentum is conserved. So that means that the momentum that you begin with has to equal the momentum that you end with. So there's going to be three applications of conservation of momentum that we want to talk about. So the first one is going to be something that explodes. So we're going to start with one object that has a certain amount of mass, and then it's going to blow apart into two objects. Each one of them is going to have its own mass and is also going to have its own speed, and so therefore they're going to have their own momentums. And an example of this would be the rocket ship. So a rocket ship has stages to it. So a rocket ship takes off, and then when it uses up the fuel in one of its stages, it jettisons the stage this way, and then that gives the rocket a little bit more boost going this way. So that would be an example of this explosion thing. Now, in order to illustrate it, we're going to use a simulation off the internet. So if you go to the internet, I want you to type in the physics classroom. Okay, are you there? Okay, and so if you click on the physics classroom, you'll see that it has all sorts of different kinds of simulations and tutorials about physics. So we're going to click on the physics simulations, and these are all the different kinds of simulations that you can be looking at, but what we want to do is go to momentum and collisions. So let's click on that one. And then these are all the different simulations for momentum and collisions, but the one that we want is this one down here that says collision carts. And then I'm going to click on this little picture here, and then I need to launch the interactive. Okay, and so I've got this thing here in which I've got two carts, and I can control their mass. So this one has a mass of 1 kilogram, and this one has a mass of 1 kilogram. I can also control their speeds by clicking on these things here. Now, we want to first do the explosion. Okay, so I'm going to click on this, and so now I've got the explosion set up to go. So notice that the two carts are connected together, and then the initial velocity of each of the two carts is set for 0, but let's just go ahead and do that just to see what happens. So if we click on start, okay, you'll notice that this one went in this direction and had a speed of negative 10 meters per second. What does the negative 10 mean? That means that it's going in that direction. A positive number means it's going in this direction. Now, did you notice that they were both equal and opposite? So why is that true? Okay, it's going to be because they have the same mass. Okay, now let's go back to our working equation here. So we're going to say the momentum that it has before is going to equal the momentum that it has afterwards. So the momentum that it had initially was going to be equal to the total mass. So when they're all connected together, they're going to have a total mass times their initial speed. And then that's going to be equal to their final momentum. But we have to break that apart into two momentums, because we got the momentum of the piece that went this way, and then we had the momentum of the piece that went this way. So that we could say that this is going to be mass number 1, or it could be the blue or the red car, times the final speed of that cart, and then plus the mass of the second one times its final speed. And also we need to put some more subscripts on this. So I'm going to put a 1 here. So this is going to be the velocity of cart number 1 final, and then this is going to be the velocity of cart number 2 final. So it's kind of burdensome to have all of these different subscripts, but it's really, really important to put them all on there. All right, so now let's go back to the simulation and fill in some numbers here, so that the total mass would be 1 plus 1 is going to be 2. So that's the total mass of the system. Okay, what was the initial speed? It was 0. So both of them had an initial speed of 0 because they were just sitting there. And then they exploded. So that's going to be equal to, on this other side, you're going to have mass of the red car. So let's say this one's a 1, times the final speed, which we just said was a negative 10. Okay, and then add that to the mass of the blue car, which is 1, and its speed, which is 10. Okay, now let's see what happens. 0 times 2 is 0. And then 1 times negative 10 is negative 10. And then this is positive 10. So positive 10 and negative 10 is going to be equal to 0. All right, so 0 is equal to 0. So conservation of momentum works. So we've just proven that. Now what do you think would happen though if we change this to, we're going to reset this. So if we go back up to here and we're going to click on the reset button. So now they're all connected together again. And let's give this thing a mass of 2. So before you click the go button on this, what do you think is going to happen? So now you've got a heavier one on this side and a lighter one is on this side. So let's go ahead and hit the start button and see what happens. So you notice that the one going this way is faster. Now could you have predicted that? So do you remember that momentum is equal to mv, so that the bigger the m gets, the smaller the v gets in order to compensate? So the red car has more mass, so it's going to have a smaller speed. The blue car is going to have less mass, so it's going to have more speed. So we can predict that. And let's go ahead and plug it into the formula here and see if it was conserved. So let's go ahead and do this calculation just one more time here. Okay, so again, it starts with 0 velocity, and so our total mass this time is going to be a 3. Okay, because we had a 2 and a 1, so 2 plus 1 makes 3, but it's still being multiplied by 0. Now don't get the idea that this velocity always has to be 0. So the two of them could be connected and be moving, and then they explode. So you can practice that with the simulation if you want to. And then over here, the mass of the red car is going to be 2. Its speed was -5. And then the other one had a mass of 1, and its speed was 10. And so 2 times -5 is going to be -10. This is still going to be 10. And then over here, this is going to be 0. So once again, 0 is going to be equal to 0. And so momentum is going to be conserved. All right, so let's now go back to the notes here. And let's do an application of using this formula. So it says a stationary stick of dynamite of mass 3 kilograms explodes. 0.5 kilograms of it travels to the right with the speed of 100 meters per second. Calculate the speed and the direction of the other piece. So we're going to use that the initial momentum has to equal the final momentum. Okay, the initial mass is going to be 3. So we started off with 3 kilograms, and it did say that it was stationary. So we're going to say 3 times 0 equals 0. Okay, then the other piece was going to the right, so that's positive 0.5, and then times its speed, which was 100. And then the other piece, how do we know that it's 2.5? So the mass of the other piece is 2.5. That's because we started with 3, and then 0.5 of it went one way. So that must mean that 3 minus 0.5 is 2.5, which is going in the opposite direction. Now we don't know what its speed is. So we're going to say 0 is going to be equal to positive 50 plus 2.5 times v. Take the 50 over to the other side, becomes negative 50. And then take negative 50 divided by 2.5, and you get negative 20 meters per second. So that's going to be the speed of the other one. All right, now why does it have the negative sign? Okay, if one of the pieces was going to the right and was positive, the other piece is going to be going in this direction, and it's going to have a negative speed. All right, so that's how you would solve momentum problems when something explodes. So now what we want to do in our next segment is do it in the opposite direction. So now we're going to start with 2 objects, and they're going to smash together, and they're going to stick together. So I'll see you in just a moment.